In this lesson, we're going to go over the angle rules you've looked at in maths up till now. Okay, so here we have 6 different types of angles. Your angle can only be one of these 6. It can't be all 6 of them. Let us start with, and I might just draw them all on one thing. So let's do that. Okay, so our acute angle is going to be anything from 0, so if we had an angle of 0, to 90 degrees. So this here is going to be acute angles. Then we come to our right angle at 90 degrees. So acute is greater than, acute is less than 90 degrees. Our right angle is 90 degrees. Obtuse is the next one, and that's going to be bigger than 90 degrees and also smaller than 180 degrees. So obtuse is going to go in here. Then we get to a straight angle, which is 180 degrees. Then reflex is anywhere in here. So that's bigger than 180 and smaller than 360. And finally, the revolution is 360 degrees. Let's say that's 90 degrees there, 180, and 360. Okay, now when we have two angles next to each other, they're going to be called adjacent angles. So that just means beside, for example. So let's say we had this, and we've cut it. These two angles are adjacent because they're touching each other. Vertically opposite angles are angles where if we have two lines that cross, the angles that are opposite each other or not touching, if there's just the two lines, such as these two or in these two as well, are vertically opposite. Now, an important thing to remember about vertically opposite angles is that they're the same. And we're going to be looking at proofs with our angles. This is an important one to remember, that vertically opposite angles are the same. Next is supplementary angles. Supplementary angles are going to add to 180 degrees. So let's say we had A and B. These add to 180, so supplementary. If we had, whoops, that's horrible. Okay, so we had A, B, and C. Here, A, B, and C are supplementary. Finally, complementary angles are angles that add up to 90 degrees, and that's going to be, for example, these two. We could split that even further. As long as they add up to 90 degrees together, you could say that here A, B, C, and D are complementary. Next, we come to angles on lines, and this is the most recent of the things you've looked at. If you are unsure or forget any of this, please do bring it to me so I can help you. The way I like to remember it is that our corresponding angles are our F angles. So if we took this angle here and this one here, when these are the two lines we've looked at over here, these two angles here are corresponding. Now we can draw our F in 4 different ways, but each time it's going to be angles that are underneath. No, that's not the right one. There we go. So these angles are going to be corresponding. Next are our alternate angles. I think of these as Z angles. And those ones are alternate. Co-interior finally is our C angle. So we have these ones and then the backwards C. For example, here we have a corresponding angle. That's this one here. An alternate angle, we could go for this one, which is this one here. And then co-interior, let's say we had this one, this one. Now, there's some important things to note when we have parallel lines. So if these lines here are parallel, then we know that our corresponding angle, let me get this, our corresponding angles, so say we had this one and this one, if these two lines were parallel, then our corresponding angles are going to be the same. For alternate angles, they're also going to be the same. So let's say this one and this one would be the same if the other two lines are parallel, and then co-interior. So let's say this one and this one. These aren't the same. Instead, they're going to add to 180 degrees. Remember, these are all proofs we can use when we're trying to prove congruence and similarity, and we'll need to know them. Make sure it is only when the lines are parallel that these facts here work. Otherwise, we still call them corresponding, alternate, and co-interior, but we can't make these assertions about them. Now we're going to quickly do one example, and the thing that we're really worried about here is the reasons for our answer. in year 9-10, we're really concerned with actually showing our reasons. So that's what we're going to be doing. Now, to walk you through what I'm going to do, here we have 70 degrees. We want to get to the x. I'm going to call this point A, just creating a variable. And we know that 70 plus this one is going to be 180 because they're on a straight line, and then we can use corresponding angles to get the x. So we're going to start by going A equals 180 degrees minus 70 degrees. So A is going to be 110 degrees. And it's really important that for every statement we make, we need to give our reason. So here we're going to say something like angles on a straight line add to 180 degrees. Okay, so we've done that one. Now we want to get to x, and we can say that x is 110 degrees because they are corresponding angles, but it's very important that we also note that they're parallel lines. Because corresponding angles, remember, if the lines aren't parallel, these two angles aren't actually going to be the same size. So we can say corresponding angles on parallel lines are equal. And there you go, we've proved that x is 110 degrees. Now it's your turn, have a go at this question. Okay, so we're going to start by finding our A. So A is, and there are different ways you could do this. You could find this angle here and then use a corresponding angle as well. But because I've given you the A, hopefully you've gone this way. So we're going to say that A is 180 degrees minus 120 degrees. So A is going to be 60 degrees. And the reason is that we have used a co-interior angle on parallel lines. A supplementary. Well, they add to 180 degrees. And now we get to our x equals A. So x equals 60 degrees as vertically opposite angles are equal.